Hello friends, welcome to Edwiki Learning channel. Please do subscribe to get more updates on the DevOps concepts. This video is part of the full course AWS DevOps Practitioner training. Please do check the description below to get the link for the complete full course. Without further delay, let's get into the video. Thank you.
Welcome back team, and let us continue the Kubernetes discussion. So how many of you feeling that the Kubernetes is interesting? It is interesting, right? Sometimes I do wonder that we are like struggling to understand the concept, how it is working, but think of from the developer perspective who has implemented this product, right? Someone has developed the Kubernetes, right? What will be their struggle to develop this, and the guy who has thought about it, maybe this is how we need to run the application, right? So it's like awesome. Well, so coming back to the lecture, right? And yes, our goal is to run my application in the Kubernetes cluster as a pod and access the application from outside world, right? As part of that, we have seen how to create a simple manifest file for deploying the pod. And once the pod is deployed, how do we access the application running inside a pod, right? Using a service, correct? And here I have introduced the service of type node port, which will be helping us to do a service port mapping to the node port that is listening at a worker node level that helps us to access the application from outside of the Kubernetes cluster, right? That's how the whole concept works. Are we good with this statement? I'm just purely using the Kubernetes terminologies this time, right? Because we are slowly, wrapping our terms from the Docker terminologies towards the Kubernetes terminology, right? So simply put, the service that I'm going to use in the Kubernetes cluster, right? This service is acting as a service discovery process, right? So the other day I said, right, the service is acting as a load balancer, right? That is just for understanding, because somehow the service is actually routing the traffic to the backend, right? Right, like a kind of a load balancer. But if I talk about the Kubernetes language perspective, right, the service is actually doing a service discovery. Why? It is actually discovering the application that's where it is running in the backend ports. And how exactly it is doing the discovery, guys? So the service is actually discovering the applications running in the pod, right, with the help of the labels and the selector concept, correct? So far so good. I just have done a quick recap. Now, coming back to this discussion, right, I have 3 worker nodes in my cluster. Each worker node has its own IP address, and you deploy a pod, which is your application, right? So in general, as of today, by default, the scheduler services are taking care of deploying the pod it into which worker node by following the default scheduling policies. So the pod may run any worker node. You are not worried about it, because irrespective of the worker node where the pod is running, right, your application will be accessible using the service that you are deploying. And to the service, you need to tell that the label that it has to look for a service discovery, right? So in general, each application should have its own service to be created, and you define the label, the selector concept, right? That's how the each service will be responsible to discover the pods matching the label to do the traffic routing, right? Good. Now the service is actually having the port map to the multiple worker nodes like this, right? So that the request may come to any worker node, doesn't matter where the pod is running, you are able to access the application. Are we good with this? Right? In this example, probably your Apache web server is running in the worker node 3, but you still able to access it from worker node 1. How come it is possible? Your service layer is taking care of, right, routing the traffic to the backend pod, right? So no matter the pod is running in which worker node, that's how the Kubernetes is treating the whole number of worker nodes as one single set of cluster nodes, and it can take care of that. So far so good, right? Then the people can send a request to the worker nodes, right? But the end user who is trying to access my web application, usually the end user will not be sending the request to the specific IP address of a worker node, right? When I look at the real time, the user would like to access the application as www dot, the website name, right? That's the end goal, correct? So what do we do now, right? I'm going to create a load balancer, which is completely a outside of the Kubernetes layer, correct? I'm creating a infrastructure level load balancer, and in our case, since I'm using the AWS cloud as my infrastructure provider, I'm using the AWS provided load balancers here. What I'm doing is, since the AWS load balancer is providing a concept of routing the traffic to the backend EC2 instances, correct? Always to your load balancer, the instances will become the targets, correct? So all of my worker nodes that we have here are actually a EC2 instances, right? So all these EC2 instances will now become the targets for my AWS load balancer. The same AWS load balancer concept that we talked about before, right? The same concept I'm going to apply now, right? So now what will happen, right? The end user who is trying to access my web application, right? The end user will be accessing the application using the specific endpoint. You see that the user is now hitting www dot the website name, let's say at shopper.com. You maintain your DNS entry that this domain, right, this resource has to be resoluted into a AWS endpoint, sorry, AWS load balancer endpoint. That way, whoever is accessing this website name, the request will be resoluted to the AWS load balancer. AWS load balancer will see that, hey, I have 3 worker nodes which are the targets. The request may go to any one of the worker node to the port number 31000, right? So whenever the request comes to any worker node on the node port, the request will be given to the service port. The service will just check for the ports having the same label. Then the service is routing the traffic to the pod on target port. Then that will be taken care by the application running in the container, and that will be responding back. This is the complete overall flow, how the request will be routed through from public internet space to the application running inside a pod in your Kubernetes cluster. Are we good with this? Right? So nothing is default here, right? So whenever you deploy the pod, right, whenever you wanted to access this pod, you need to create a service layer within your Kubernetes. And the service that I'm creating here is of type node port sometime back, right? So now and of course, the other day I have deployed 2 manifest file, right? One manifest file for a pod, I mean to say for your application deployment. The other manifest file is to deploy a service alone, right?
Sir, one
Now,
question.
yes,
Uh,
please.
so you told that we are not define. I mean, even though the other two nodes that doesn't have the label, it will deploy that application on the other worker nodes, right? So that service layer will take care, right?
I
As
think,
per the yeah.
yeah,
Yep.
I think your question has to be revised in a better way, and right. So the pod may run in any worker node, doesn't matter, as long as the pod has a label matching to the selector label that you define at your service can route the traffic to that particular pod, and it may run in anywhere in your cluster, in any worker node, right?
Yeah, but worker node 2 only has login hyphen app, so it will only take the loads of login hyphen app, right? I'm confused here, sir. So
Okay, so we'll park the question for now, and we'll see once we implement this setup, right? I just
I have one
yeah,
question.
yes, please.
Suppose I have 10 pods running in 2 node servers. You said each application has one service, right? So it means application one has one target. The port is 80 and service is 80, and application two target 80 and service 81. Like that, service port will be vary like 80, 81, 82, or how it would be like only you said one service for one application, right?
Well, right. So the port that it has to listen at a service side is your responsibility to set it up, and you can define any port that you like it at a service port. But it's better to have a same number that what is being used in the target port of your pod, but it doesn't be the same. It can be any number that you like to keep it in your service. The service port is actually binded to the node port. The node port is unique in the sense the 31,000 port should be mapped to 80 port of your service. The 32,000 port may map to 80 port of a service B. 33,000, I'm to say an example, right? The other port can be mapped to port number 80 of another service C. So each port that listens at a worker node level is actually binded to the specific service A, service B, service C, so on, so on. So whenever the request comes to the specific port number at your worker node, it know that that has to be get routed through to which service, and the service know that it has to be routed to through which pod based on the labels that we define, which is the same concept that we do in Docker port mapping level. Like each service should be get binded to the specific unique port at your host machine, right? So here also, I'm trying to ensure the unique port at a worker node level, which is the node port that should be unique. And at your service level, at your pod level, it's up to you which port that you would like to use it. Because within the Kubernetes level, right? So the Kubernetes will most worry about the label concept and the service name concept. It's not worry about the port numbers are same or not. So the multiple pods can listen on same port number. Multiple services can listen on same port number. It doesn't care about that because the Kubernetes is always working through the labels and the selector concept in order to identify the target, and the service will be identified using the service name itself. Though we are calling out that the pod and the service has its own IP, the IP is not being used effectively at a first place. Of course, the IPs are using at a backend by the Kubernetes, right? But for us, we are not caring about the IP. We only care about the labels and the selectors and the service name, and that's how we need to know the configuration. So the entire Kubernetes will rely on the service and the label concept only for identification. It's not worrying about any other thing. So that's where the labels are playing the key role here to do the whole architecture to run a multiple applications inside your Kubernetes cluster.
So node port will be vary for applications,
Of
right?
course. And that too, I'm going to keep on modifying this diagram, guys. Whatever is covered today on this slide is what I'm sticking. Yes, that is true. But we'll be keep on modifying this further and further to the better architecture, because if I have some 100 applications, 100 unique applications that are running in my Kubernetes cluster, It's very hard for me to use 100 unique node ports at a worker node level, correct? It's very difficult to manage to have a specific dedicated port for every service when you have multiple. So to overcome that situation, we are going to uh, change this architecture further and further to the next level. But we can't jump onto the final architecture at one go. So I'm slowly, trying to modify my architecture towards the final goal. And I'm going to that, the whole structure will be keep changing. I may not be relying on the node port also down the line when I'm changing this architecture to the further.
All right. Thank you. Thank you.
Now, at this time, I'm trying to slowly combine or integrate the Kubernetes concept with the AWS load balancer concept. AWS load balancer is outside of the Kubernetes as an infra layer, and the service and the things are within the Kubernetes, right? So how do you go about it, right? And the service port number that you use can be anything that you like it, right? There is no range being specified. The range is specified only to the node port that is listening at a worker node level that has its own specific range that the Kubernetes is looking for, right? Now, so as I see the questions in the chat window, right? As of now, I'm not worrying about the security groups anywhere in my slide at least. We'll take that question later part, right? Not to deviate to the other thing because that's part of the deployment probably. Now, I meant to say EKS deployment, right? Now we'll see how to deploy a load balancer for this, correct? So let me see what is the current state of my EKS. I just have deployed a EKS cluster using my Terraform code. And now what I do is I'll just try to create a config, right? AWS EKS update -kube config, the name of the cluster, and US East 1 is my region. Well, you see guys, actually since I am running the commands on my Windows terminal, right, the Windows is taking a little longer because that also depends on my laptop performance, other things, right? So down the line, I'm going to run many commands, right, to show you different things. Maybe it's hard for me to run all my commands in the Windows CMD prompt because each command is taking longer, right? So what I do prefer is rather me running these commands on my local system, though it is working just for considering the time that it is taking to execute the commands, right? I would like to run these commands on any one of the EC2 instance itself. Getting me? What I do, as of today, my local system is acting as a Kubernetes client, correct? The system where you are running the kubectl command, that system is called as a Kubernetes client. Are we good with the statement? The kubectl is the Kubernetes client utility which will be helping us to connect to the Kubernetes server, which is the API server in this case, right? So now I wanted to use the EC2 instance as a Kubernetes client, so it's very flexible to run the kubectl commands to go through the whole structure because we'll be having the partition, right? So it's good to have. So what I do is I'll just go to AWS EC2, right? And currently I could see that there are two instances because these two are my worker nodes, right? So I'll go and create one more EC2 instance. right? So this instance, I'm using it as a Kubernetes client. Make sense? Kubernetes, in shortcut, can call it as a K8s, which refers that there are 8 characters in between K and S in the Kubernetes term. That's what the Google has identified some shortcut. So that's where we can call it as a K8s. Now let me go ahead and deploy a server. This I'm using it as a Kubernetes client, no other reason. Getting me? Just because I don't want to run the commands on my local system where it is not that much, good. So I'll just go to this instance. I'll use this as a Kubernetes client. So I'll just take this public IP. Let me logging it to this instance. Well, now I need a kubectl command line utility here, right? Let me install the kubectl. So what I do is I'll just go to Google kubectl installation. Let me navigate to the portal to get the kubectl, and I wanted to install the kubectl on the Linux system. And let me see the steps. And here I can see the command to download the kubectl utility. And I wanted to specify the version as well. So let me take this command, copy this command. Now let me specify the command. I wanted to download 1.28 version in this case. I just have modified the version there. Once I download the kubectl, let me give the execute permission for my kubectl. Correct. Now what I do is I'm going to move this kubectl to the USR bin location. Why I'm moving this file to that location? Because usually this is the location where most of the Linux commands will be there, right? So I'm just moving this into this location so that the path environments are already been set, so that I don't need to worry about it. Now let me see the kubectl get nodes as an example, right? So at least my kubectl command is working, right? I'm not getting, let me see, kubectl version, right? It's working. Now I need to set up the kube config, right? Correct. So because in this system, the kube config is not available to connect it to the API server that you like to using the certificates. So all what you need to do is I need to run the AWS update kube config one more time here to generate the credentials, or the credentials that are generated in the local system in the .kube folder. We need to copy that file at least. Either the way it is fine, right? So what I do is I'll try to generate the credentials one more time. So, but I need a access key and the secret access key, right? Following me? So the credentials that I have used in my local system, right? I'm going to use the same credentials. I'll keep these credentials in my EC2 as well, because I need to use the same credentials in order to generate my kube config. So let me run AWS configure for this case, access key, and this is the secret access key that is used to deploy this EKS cluster, US East 1 region. Done. Now I will run AWS EKS update hyphen kube config hyphen name ed hyphen EKS hyphen 01 is my name, and the region is US East 1. Now using these credentials, it is actually generating the certificate, and that certificate is by default updated it in the .kube location in the file called config. Now if I run kubectl get nodes, let's say, it's working. Are we good with this, guys? Let me clear the screen. Now we have got a better screen to run my kubectl commands rather running it in my local system. So far so good. Now let's start deploying the application, right? So in my Visual Studio Code, I spent some time to create a manifest file, right? So first let me deploy the pod, correct? So I mean to say the application deployment, correct? So I'll copy this manifest file because I'm running the commands in my EC2 client, right? So let me copy this manifest file to here and let me run the commands there, right? kubectl is the Kubernetes client which will be helping you to connect it to the API server. There is no other way to connect it to the API server except the kubectl as of today, guys, right? So kubectl, now apply -f pod.yaml, right? So when you're running this command, right, it's very basic Linux concept that in which location you created a file, whether do you have the file or not in the location, then you run the command called kubectl apply -f pod.yaml, right? Because it is trying to get this file and send this file to the API server. Because I'm searching here because I do get a lot of questions saying that this command is complaining that the pod.yaml is not found. You should ensure that you are running the command from the present working directory where the file is exist, right? It's a very basic Linux concepts to understand the file and directory structure. Agree with me? Now let me run this command. It is going to send this file to the API server, and now you see that your pod is getting created. Good. So I'm not really worried about the pod is created in which worker node at this time. Let it be in any worker node based on the default scheduling policy. Now to access this application, right, I need to create a service, correct? So believe me, guys, for any application that have been deployed to run as a pod, to access the application, you need to create a service. Through service only, you are going to access the application running in the pod. Now let me deploy the service. And again, right, I have got the service manifest file here to deploy the service. And the manifest file that you see here, this is actually a uh, service of type node port. You see the type here, guys, in this manifest file. The node port service in the sense, right, the service will be created with the port number 80 in this case, which is responsible to route the traffic to the target port, which is listening at a pod side. To which pod? The pod that are having a label called zone, which you have been specified in the selector section. And the service is going to get the traffic from the node port that is listening at a worker node side. Are we good with this explanation? This is what the service is doing here. And I given any information that needed by the service here. But I don't want to use this node port service alone. Why? As I said here, I wanted to integrate my Kubernetes with my AWS load balancer, right? So it is possible to tell to your API server that, hey, API server, I wanted to use the AWS load balancer at a cloud level. Can you help me with this? So all what we can do is when you are deploying the the service, the type can be a load balancer service. I'm just changing the type, guys. Okay. Rather than deploying the service of type node port, now I'm deploying the service of type load balancer. That's only the change. The remaining all information is as it is. What will happen, right, when you keep the type as load balancer, the Kubernetes API server understands that it has to be integrated with the AWS load balancer. Then it will try to create a AWS load balancer automatically for you. Let me see that. So I'll copy this service of type load balancer now. This is lb.ml, right? Now let me do kubectl apply -f lb.ml. kubectl get service is the command to see the service resources of your Kubernetes cluster. Now you see that your service is deployed as a load balancer. When it is deployed as a load balancer, now you see that it is actually attached to a external IP, which is your load balancer in this case. You see, guys, this is actually a AWS load balancer endpoint. The rest, everything is same. The only difference is the Kubernetes API server itself is taking care of creating a AWS load balancer for you. If you go back to your AWS and just go to the load balancer tab over there, right? You see that it is actually created a AWS load balancer, correct? So by default, it is actually creating a AWS load balancer of type classic, but you can tell what type of load balancer that you wanted to. There are different type of load balancers, right? Classic application load balancer, network load balancer. More or less all the load balancers are doing the same thing, routing the traffic with slight differences, right? So by default, it is creating a classic, but we can tell in the manifest file itself that what kind of the load balancer that you wanted to. For now, let it be keep simple, right? It actually created a load balancer for you, and in this load balancer, it all, you go inside, right? And here you can see the target instances. You see that the both worker nodes that are part of your part of your Kubernetes cluster are already added as a targets to the load balancer. Everything is taken care of by your API server itself to map all these things. I got my two worker nodes as a targets here. Both are in service here, right? And if I look into the listener section, you see that the traffic it is getting on port number 80, and it is routing to the 31,000 port of your worker node. The moment when the traffic comes to the 31,000 of your worker node, we know, right, that will be routing to the service. The service will go to the pod. That layer is exactly be the same. So you may be asking here now, how would the Kubernetes API server is taking care of creating a AWS load balancer automatically for you? If I go back to the Kubernetes architecture, right, you see here the Cloud Control Manager is one other service that is currently running in the Kubernetes control plane. The Cloud Control Manager is actually be responsible to create certain infra resources, cloud infra resources automatically when it's needed for the Kubernetes integration. Are we good with this? Right? So let's say if you are using the Kubernetes on AWS, it will take care of some of the AWS resources to be created automatically as needed. If it is on Google Cloud, let's say it is trying to create some of the Google Cloud related, something like this, any cloud, right? So because of this, it is actually created a load balancer for you. Now your job is easy. In order to access this application, right, all what you need to do is take the DNS name. This is the load balancer endpoint. Now just try to access this application from the browser. Let me see if it is configured with a proper security groups. Well, so this is my load balancer at my AWS level. Now, what happened to my security groups? Yeah. This is interesting. So technically, I should be getting the edit option here in order to edit my security group rules to allow the port number. So for some reason, now it's not allowing me to edit the security groups. So the classic load balancer is not recommended to use. That's true, right? So the classic load balancer will actually be deprecated. Not sure if it is already deprecated by now or it is going to be deprecated, but somehow it should not be. Yeah, I can see that the classic load balancer is still there here. That means it is not yet deprecated, but soon it will go away. That's okay. That's fine. So I'll try to create a application load balancer. Okay. For now, it is interesting. You see, it's working now. It's not the right one, guys. Clear the screen. Target. Okay. Security. Security group ID. I did nothing, guys. My website is working. Okay. So it might have been it might have been taken some time to make the things reflected. Okay. So I can see that my website is now working. I'm just accessing my my load balancer endpoint here, right? Now it's working actually. I did nothing. So somehow it took some time. But anyway, using the classic load balancer is not recommended. I'll definitely talk about how to deploy a load balancer of your required type bit later time. But this is to get started with, right? Yes. Now this endpoint, you can add it to your DNS and you access it as www dot whatever the name that you like it, right? So simple. Now you don't need to worry about the worker node IPs and all these port numbers. The traffic is routed via the load balancer. The moment when the load balancer is routing the traffic to the worker node on the node port, that will be taken care of. So far so good. Now, so let me come to the scenario here, guys. So I'm just bringing multiple presentations just to get more clarity here. What I did so far is I actually written a simple manifest file to deploy the pod, correct? And when you run this manifest file, it is actually doing the application deployment. As part of this deployment, the pod will be get created and will be listening on the specific target port with some labels that you defined in the manifest file, right? And to access this application, we are actually deploying the service. We have seen two type of the services here. One is the node port service, which will be helping us to access the application on the specific node port of your worker node. The other one is the load balancer service, which I actually try to create a AWS level load balancer as well and do the whole integration automatically for you, right? So when you deploy this as service, then it actually takes care of, right, preparing all this stuff. You see this? The service deployment will do this, creating a service of the service port and the selector for the labels and the node port and doing the mapping from the node port to the service port. All this stuff will be done by your service deployment, and your service will be identifying the pod based on the labels that have been given. Are we good with this? The external user whoever is trying to access, the request is coming to your worker node. Of course, if you deploy the load balancer tab, it will come to the load balancer, then it will come to the worker node port number. That's how it is working as of today. And this is what I have seen. I have shown you the load balancer service on top of your node port, correct? So if you see this slide, the type is load balancer here, correct? So then it will take care of deploying the load balancer as well. You see this slide? The service definition of type load balancer is actually creating the whole stuff, the Kubernetes layer as well as the external load balancer as well for you. Now the external user can request the or access the application going through the load balancer. So far so good. Now
So node port service is only restricted till the Kubernetes level, right? So
yes, the node port service is responsible for binding your internal service to the node port that is listening at a worker node level.
so we are creating ALB in general, like not like how we do normally on the AWS infrastructure.
Yes.
Okay.
Now, so this is little clear, and I think I have went through multiple times here, but looking into the chart window, because I don't want to miss out any open question there, right? So when you are deploying the load balancer service, right, that is just the type change. Rest of things are same. And if you see this architecture, right, your service has a service port, your node has a node port. It is on top of the node port service that you deployed. It is just creating the AWS level load balancer and binding that to the worker node. That is the extra thing that it is doing. The rest, everything is same. That's the reason I'm not doing any changes to my ports concept here. It is still required all the 3 ports that has to be, right? Because the whole concept is same. The only change between the node port and the load balancer type is the outside of the Kubernetes, this AWS load balancer stuff will be get created and will be get binded to your Kubernetes flow. That's it, right? That's only the additional thing that it is doing on top of the general general node port service, what it is doing. Now, as of today, the whole stuff is working as expected, right? And I can see my web application is working here. Now, the question for you here is, what is the case if my pod gets terminated for any reason? Let's say here my pod is currently running, right? So let's say my pod gets terminated for any reason. I'm just simply deleting a pod just to showcase that for some reason, let's say the pod got deleted. Now, do you think your website will be accessible here? No, right? It will not be accessible. That means as of today, I'm able to run an application and I'm able to access the application, but I'm not solving the problem of high availability, correct? There is no high availability at this stage. There is no self-healing. Self-healing in the sense, if my pod gets deleted for any reason, it is not creating a pod automatically again, right? You see, there are no pods, right? So the pod is not recreating automatically. So now the time to provide some high availability for my application, so that even if the pod gets terminated for any reason, my application should not go down. It should be accessible for me. If my pod gets terminated, it should be recreated automatically, right? Just to recovery from the failures, which is called as a self-healing capability, right? So to get these kind of the high availability features, right, and we need to depend on some of the Kubernetes controllers. Kubernetes has come up with the concept of controllers. These controllers will give all these additional benefits that we talked about, like a high availability, self-healing, right, and other things. Now I'm introducing you the Kubernetes controllers, and there the very first controller that I would like to talk about is the replica set controller. So what is replica set controller and what it is doing exactly? We'll see the behavior now, right? So I see a question in the chat window, right? Can we create a AWS load balancer manually? Yes, you do, if you would like to, right? At the end of the day, it is just a matter of attaching your worker nodes to the load balancer, right? If you don't want to do automatically by a Kubernetes, you can do always using your own configuration too, right? Thank you. So coming back to the replica set controller, right? We'll see the behavior here. To the replica set controller, I'm going to tell that, hey, replica set controller, I need my application to be get deployed with how many number of replicas. You just define that. Then it's the replica set controller responsibility to ensure that your application is always running with this many number of replicas that you have been defined. Just for understanding, you can always compare the replica set is equivalent to your AWS auto scaling group. This is just for understanding, guys, not for the actuality, right? So in AWS level, when the application is actually running on the direct EC2 instances, right, you used to go with the auto scaling group and specify the minimum, right? Saying that, hey, I need at least minimum this many number of servers, so that if one server is down, I have another server available to serve the application, correct? The same thing I'm going to achieve here, right, using the replica set controller, but here I'm caring about my pods, correct? So running the multiple pods of the same application is now recommended, so that if one pod gets down, the application still be available, accessible on other pod. Agree with me? The previously the statement was like this, right? If one EC2 server is down, the application is available on the other EC2 instances, correct? But now I'm worrying about the pods. If one pod is down, my application is available on the other pod. Let's say, just to take this example, right? Whenever you deploy the replica set controller stating that I need 3 replicas of my pod of my application, then it is going to deploy the application it into total 3 number of pods. Right? Whenever the replica set controller is actually creating the pods with the replicas that you defined, the 3 replicas, and of course you given the selector section here as the label, right? That means you are telling to replica set controller that the pods should be get created using which label of pods that you are responsible. You are just specifying this whole configuration. The replica is the terminology that we use in the Kubernetes, which is telling that the total number of pods that you wanted to run for your application. When the replica set controller is creating a pods, the number of pods can run in one single node, can run in multiple nodes. It's up to the scheduler decision, guys. The replica set controller will only worry about whether do I have 3 pods or not. That's it. The 3 pods may run in one single server, may run in multiple server. It doesn't care about it. The replica set controller is not caring about it. Who will decide that, guys? The pods should be run in one server or multiple servers. That is the scheduler policy. The scheduler policy will decide where the pod should go. The replica set controller will only tell that, hey, I need 3 pods with these labels. That's it. Where those will be running, let the scheduler service is deciding that. But in general, it's better practice to have the pods are spreaded it into multiple worker nodes, not running in the single worker node. Because if at all your pod gets crashes for any reason, if the pod gets crashes, then the replica set controller understands that, okay, look like I have only 2 pods running. with the labels that I'm responsible. No, I should need 3, right? Let me create a 1. So it will request for one more pod will be get recreated again because it has to maintain 3 replicas at all the time. That way, if the pod gets terminated, right, then the self-healing will be happen. It will be recreated again just to meet with the number of replicas that have been asked for. If at all, for any reason, if your whole worker node is down, let's say the worker node 3 is down. Now the replica set control sees that, hey, I have only 2 pods. No, I need 3 pods. So it will request for one more pod. At this time, since my worker node 3 itself is down completely, your pod may come up in any other worker node wherever it is possible. And you see, again, I have 3 worker nodes with me. Sorry, 3 pods with me. If you look at all the 3 pods are running with the same label because that is more important. If you have all the 3 pods running in single worker node, then if that worker node is down, all the 3 pods will definitely come up in other worker node. That is true, but it takes some time, right? So your application will be down during the time when it is moving the pods to other node. Hence the reason, better to keep your pods spreaded it into multiple worker node. If one worker node is down, let's say like this, right? During this time, during the movement of the pod from the failure worker node to the healthy worker node, your application will still be running because there are 2 more pods running healthy on the other worker nodes. Now, who is this replica set controller? Who is taking care of the replica set controller, right? So if I go back to my Kubernetes architecture one more time, and here you see the control manager service that I talked about. The control manager is one of the service that is responsible to monitor, run your pods and reporting to your API server, right? The replica set controller that I'm talking about is one of the controller handling by the control manager service. Now since we know that the replica set controller is responsible to create a pods, right? So I'm not going to create a pod, correct? Let me go back to the slide again. Now tell me guys, who is going to take a decision to create a pod? Is it that we manually? No. I always request my replica set controller. Hey, replica set controller, please ensure my application is running with 3 replicas. So hence the reason, now onwards, I'm not going to deploy the manifest, which will be of kind pod to create a pod, because if I create a pod myself, the way how I did it before, that is not being tracked by my control manager. So I'm not going to deploy the pod using this method now. Rather, what I do is I will be creating a manifest file called replica set controller. In this replica set controller, I'm going to tell, hey, this is how you need to manage my pods. So the time to create a manifest file for my replica set controller. I'm sure I may be having some manifest file with me. Let me try to take that. Right. So this is the replica set controller manifest file. It's very simple again. API version to deploy the replica set controller type of resource. Always the API version is apps/v1. This is all come from the documentation, guys. Right. The documentation says that if the kind is replica set, then the API version is apps/v1. Good. Metadata, under that you give the name of the replica set controller. Let's say this is a web server replica set. Same thing, right? API server kind metadata, under the metadata the name, then the spec section. This is the specification of your replica set controller, how it has to work. Under the spec, you need to tell that how many replicas that you are expecting. You define that, hey, I need 3 replicas, okay? And you see that the indentation, guys, I'm maintaining this space just to tell that the replicas is actually the property of a specification. So I just need to tell 2 things to my replica set controller. One, how many replicas that I need. Second, the selector section, that is where you need to tell, right, what is the label that it has to look for, correct? Or else how it know that how many pods are currently running. So whatever the label that you said here, then the replica set controller will be keep searching for the pods with the same label. If it is not finding the right number of pods matching to the replica, it will try to create a new one. For now, let me remove this, not needed. Let's say, right, it is searching for this particular app, I'll say web, okay? I'm changing the label. Let's say the replica set controller searching for the pod having this label. Let's say the pods are not found. It has to create a new one, right? If it has to create a new one, you need to tell how it has to create a new one, correct? You need to tell the pod specification as well, using which image it has to create all these things, right? That will be going under the template section. Under the template, you would define that how it has to create a new pod. Remember the concept. In the AWS autoscaling group, right, you define that I need a 2 minimum servers. But how it is going to create a server, you need to define it using the launch template, correct? In the launch template, you define the configuration, how it has to. Same thing. So now in the template section, we need to define how a pod has to be created. You see, sometime back I have wrote the pod manifest file, right? Saying how my pod has to be created. So take this configuration as it is, and let me put that under the template section. Maintain the indentation. Are you good with this?
So just one clarification here. While creating the worker node using the Terraform, we never configured any auto-scaling launch template or anything, right? Just because it is a fully managed.
As of now, I have created a auto scaling group at the time of me deploying the EKS cluster, right? By specifying that the number of EC2 instances that I would like to manage in my auto scaling group by specifying the scaling configuration. I have shown you that there are 2 auto scaling groups that are actually created, which will be handling the EC2 servers, which doesn't help me to scale my pods. Okay, this is just for my worker node side.
Yeah, my bad. I think I just missed that. I forgot. Yeah.
Thank you. So this is how I'm preparing my replica set controller, guys.
I have one question. Suppose like if the container in pod is dead, then will the replica set keep spins up the new pod, or will it try to restart the dead container?
We'll see that.
Okay.
Right. So let me deploy this replica set controller first. Let me see what's happened. I'll copy this. So as of now, if I see here kubectl get pods, nothing. Now I'm deploying the replica set controller, guys. I'm not creating a pod, right? I'm creating a replica set controller that will create a pods for you automatically. Kubectl apply -f, specify the file name and hit enter. That's okay. It is the indentation issue. So you see that the indentation is not correct. Let me go back and correct the things. Okay. So the specs should be here. That's what it is complaining. It should be at the same level of template. It's typical to see all these indentations, but yeah, we can take the reference from the existing documentation and always can compare how the indentation can be. Really? Selector, template, metadata, spec. Selected template. Where is metadata, guys? This is missing. I think I did not copy from the metadata when I'm copying from my pod, right? You see, it has to be come from the metadata. Let me add that section. Under the template, it should be metadata, right? The name should be under the metadata, label should be there. These are the two labels that I'm giving here, and this is the label that I'm asking for. So ensure that I'm giving the same label in my template as well. Then only the pod will be created with the same label. My replica set controller can look for the same label when it is trying to ensure that the minimum number of pods are available. Now it will be under the template. Now under the spec, I'm creating the container information, right? Looks good. Let me copy this one more time and let me try to deploy this.
Sir, you're using pod template here, right? Just confirmation.
And of course, the template that I'm specifying here is it should be a pod template. I'm telling to my replica set controller that, hey, whenever you wanted to create a pod, how it has to create a pod, what should be the pod name, what should be pod label, which image that it has to use to create a container. That is the information that you need to tell, right? Then only the replica set controller know how it has to create a new pod, right? So kubectl apply. Let me try to deploy this one more time. Now I see that the replica set controller is created. We'll see what's happened now. kubectl get rs is the command to see the replica set controllers. I can see that the replica set controller name, it is defined as the desired, in the sense the one which you have been asked for, right? You asked for 3 replicas. Okay, currently yes, 3 replicas are deployed. 3 are actually in a ready state. It's deployed 10 seconds ago. Now if I do kubectl get pods, right, you see that there are 3 pods are running. Tell me guys one thing, all these 3 pods are running in the same application, correct? Because all the 3 pods are actually deployed using the same image. So all the applications, sorry, all the pods are running with the same application only because the image is same. The request may come to any pod, the response will be the same, correct? The end user who is accessing the application from the browser, right, this request may go to any pod, the response will be the same. Agree with me? Now who is taking care of, let's say in this case I have 3 pods, right? And if someone is accessing the application from the browser, this request may go to which pod out of these 3 available? Who will take care of that? Service, right? As I said some time back. So when you look into the service configuration, I got one more slide for you, right? So whenever you deploy the replica set controller, it is actually creating the multiple replicas of your application using the same template. That way it ensures that the same application is running in all the pods, right? Now you have a service deployed. The service is now responsible to route the traffic to the backend pods based on the labels that have been specified, correct? So the service is now responsible, right, doing the routing within internal to the Kubernetes cluster. I'm not worrying about the AWS now, right? Somehow the request may come to AWS load balancer. From the AWS load balancer, the request will come to the service that is defined within internal to the Kubernetes cluster, correct? That process we already familiar. Once the request come to my service in my Kubernetes cluster, how it is taken care of is the matter now, right? The service which is there at my Kubernetes level will now take care of routing the traffic to the backend pods based on the labels that it is identifying. In my case, all the 3 pods are with the same label. Now it will follow the round robin fashion. One request may go to pod 1, another request may go to a pod 2, another request may go to pod 3. It will try to distribute the traffic to all the pods, whatever is running over there, correct? So here the service is doing the service discovery responsibility to identify the services where it is running in, and as a service, the application. And also, whenever any pods are unhealthy, let's say in this case, not healthy, unhealthy, let's say the pods are terminated, then your service will still be routing the traffic to another pod, whichever is running currently, right? So that way, the end user will not feel any downtime. So there are 2 pods that are currently terminated, but still there is no downtime because the request will come to AWS load balancer, then to the Kubernetes service, then to the pod, whatever is currently running in, the response is positive. The AWS load balancer is only the responsible guy to route the traffic from outside of the Kubernetes cluster to inside a Kubernetes cluster, no other reason. Because the services that I'm creating in my Kubernetes cluster is responsible only within the Kubernetes. Who should be care about getting the traffic from outside to inside, correct? From outside to inside, that is what is the AWS load balancer is doing for us, because AWS load balancer can bring the traffic from outside to the worker node port number. Once the traffic come to the worker node port, then your Kubernetes can pick it up and can do the port mapping and can do the lot of stuff internally. Whenever the pods are recreated again, right, the service will automatically understand that, okay, there are 2 more pods with the same label. Let me start distributing the traffic. Getting me, guys? So let's say if the pods are terminated, who is responsible here to create a pod again? If the pods are terminated, who is responsible? Replica set controller is responsible to create a pod again with the help of the template that you have been defined in the manifest file, because it is not matching the replicas that you have been asked for. Whenever the replica set controller requesting for the pods to be created, again the scheduler service will come into the picture, which will be verifying where the pod has to come up. Once the placement is decided, once the worker node is decided where the pod has to come up, then the pods will be created with the template section. Once the pod is back running, the service will automatically identify them because it is always searching for the labels. As and when the label is found, yes, the request will be routed to that new pods as well. That's how the service is doing his own job. Now, let me come back. Hence the reason, now let's say I have one pod that is currently running here, right? What I do is kubectl delete a pod and specify the pod name. I'm just deleting one of the pod, guys. Right? Now let me see how many pods are running. You see, within seconds, right? Within 4 seconds here. 4 seconds is like age again, right? Within seconds, I could see that the pod is recreated. Why? The replica set controller has to maintain 3 pods, right? The moment when you delete one pod, it is actually creating a pod again. Are we good with this? That is how, right? Always it is trying to ensure the number of replicas are running for you, and the business will continue to be running. So if you look at the, I think let me come here again, right? If I look into this output, right, currently you see that one pod is running it in one instance ending with 107. The other two pods are running in, the IP ending with 86. That means what? It's running in two worker nodes for now. That's okay. So what I can do, right? Maybe I can go and terminate one of the instance, right? I'll go and terminate the EC2 server, which is ending with 107. The pod that is currently running in that worker node will be get moved it into another worker node automatically. So I can just go to instances. Let me see the EC2 server, that is the one which I wanted to. 107 is my target, right? I can see my IP here. So I'm just trying to terminate this EC2 server. This is one of the worker node, guys. I just did it. Now tell me, guys, who is responsible to recreate this worker node automatically for me?
Autoscaling group.
So creating a worker node automatically will be done by the AWS autoscaling group, because AWS autoscaling group is there here to take care of the node level, node level high availability or node level scaling, whatever, right? So now inside the Kubernetes, now I'm talking about outside of the Kubernetes what's happening at a worker node level, and inside the Kubernetes what's happening, right, related to your pods, right? So here if you see, once the node is down, it takes some time. The moment when the node is not available, your pod will be definitely moving it into another healthy worker node automatically, because the replica set controller always has to ensure that there are 3 replicas are running for you. kubectl get nodes. So I can see only one node at this time in my Kubernetes cluster, because one node is actually taken out. That's actually terminated. Why this is not moving my pod still?
Was your Terraform template used to create the uh, auto scaling group as well, sir?
I have went through the EKS one more time. This is where I have specified the scaling configuration, that my AWS level auto scaling group should be whatever the configuration, right?
Oh, oops.
I'm just seeing the behavior now. You see now the pod is actually coming online 26 seconds ago. Now you see that where it's running. Now all the 3 pods are running in the same worker node, because one pod was there in the other worker node. That node is down. So it's automatically moved it into another healthy worker node. Are we good with this? So within the Kubernetes level, the replica set controller is taking care of moving the pods from the failure worker node to the healthy worker node to ensure that the number of replicas are running as expected. Good. From the outside of the Kubernetes, from the worker node side, right, your server will be recreated by using the AWS load balancers. Sorry, AWS auto scaling group. So I need to see which is the auto scaling group responsible for that. Maybe the
But
other one.
now there is a problematic situation, right? I mean, not a problematic situation. It's a so again once the other node comes up, so that will not have any kind of any kind of a pod, because already the 3 pods are already running in the same EC2 instance, right? It's running on 86. Now once the other EC2 instance or the worker node will come up, it will not have any pod running. because we have already defined as 3 and 3.
Yeah, that's true. Sorry, I think I kept you on mute again. Yes, that's true, right? Now I see the get nodes command. Yes, the 87 seconds ago, one new node is came. You see? That's the beauty of AWS auto scaling and the beauty of replica set controller within the Kubernetes. I'm trying to take the help of both. Okay, my node is back. Now it's running with the 2 worker nodes. Good to have, right? And I'm running with 3 pods that I'm trying to. That is also good to have. That's okay. My requirement is I wanted to run 3 pods. My 3 pods are running. It doesn't matter at this time. My pods are running in 1 worker node or in the 2 worker nodes. So the second worker node that is came up here just now is empty at this time. There are no pods here. But as and when you deploy the pods again and again, right, it's definitely try to schedule it over there as well. But as of now, that is empty because you have only 3 pods that are already running in other worker node. If you wanted to do spread it into the new worker node again and all these things can be possible. We'll see about scheduling policies later. For now, I'm not worried about if my worker node is empty at this time. That's okay. I just need 3 pods. My 3 pods are running wherever it is. Not a worry. Correct. Now, the replica set controller that I'm using here is responsible to maintain the replicas that you have been asked for. That's it. That's the goal of your replica set controller. Okay. The replica set controller is not providing a few other benefits that I'm looking for. For example, right? I wanted to tell that what will be the CPU and memory capacity that I wanted to specify for my pod, or maybe I wanted to tell to my Kubernetes that, hey, please do a health checking of my pods. Got me? Sometimes, your pods may be running, your pod may be running, but this pod may not be healthy. Correct? Possible, right? The pod may not be healthy for some reasons. So how a Kubernetes can ensure that the pod is healthy or not? If it is not healthy, it will try to restart the process again, correct? So to do the health checks and all, right, the replica set controller is not capable to do all of this for you. Hence the reason, rather me using the replica set controller, I'm going to take the help of one other controller provided by the provided by the Kubernetes to get few other advantages that I'm looking for. Are we good with this? I'm just doing the further improvements here. The other type of the controller is called as a deployment controller. The configuration is exactly be the same, no difference, everything is same. The kind I'm changing from replica set to a deployment. That's only the difference, guys. The exact configuration. What is the deployment controller? The deployment controller will give you few other benefits or add-ons on top of your existing replica set controller that I talked about. We'll definitely talk about the add-ons or the benefits that I'm going to get using the deployment, but let me deploy this deployment controller first. For that, let me do the cleanup, guys. I don't want to use this replica set controller. Getting me? kubectl delete the replica set, specify the replica set controller. When you delete the replica set controller, automatically the pods will be get deleted. Agree? Correct, no? Because the pods were actually maintaining by the replica set. If you delete a replica set, the pods are deleted. That's okay. I just did the cleanup now. Okay. As of now, nothing is in my system. All the pods are gone. I don't have replica set as well. Now, I wanted to use a deployment controller. Let me copy this deployment controller manifest file. Let me deploy. kubectl apply -f deploy. Done. Now let's see what is this doing. kubectl get deploy is the command to see the deployments. We use the term called deployments now, right? kubectl get deploy to see the deployments. You can see the deployment name, right? Maybe I can change the name, guys, but sometime back it was replica set. I given the name as -rs. I did not change the name. Don't get confused with this name. It can be any name that you specify here, right? So I see the deployment controller, and it is telling that inside this deployment there are, right, inside this deployment there are 3 replicas that you have been asked for, and currently yes, there are 3 replicas in ready state. All the 3 replicas are up to date. All 3 are available, deployed 14 seconds ago. Now the replica set controller, what was doing before, right? The same responsibility is now taken care by your deployment, guys, correct? Because now I'm deploying the deployment, and now I'm telling that my replica count should be 3, and these are the pods that I wanted to look for the labels, and this is the template to create a pod. Pretty much the same configuration that I have given for my replica set controller, now I'm giving it for my deployment, correct? The deployment is now responsible to take care of all the responsibility of the replica set controller. Additionally, it will give you a few other benefits as well. If you look at here, right, kubectl get rs command, you see that the replica set controller is actually created. Now this time, who created a replica set controller? I did not created it manually. I created a deployment. The deployment taken care of creating a replica set controller automatically, and the replica set controller taken care of deploying the pods based on the replica count that you have been specified. Are we good with this? That means still the replica set controller is there, and the replica set controller is managing your pods. That is not changing, but the only change is you are deploying the replica set controller explicitly. You deploy the deployment that takes care of, right, replica set controllers automatically. Good. Why should I deploy the deployment? Definitely it is taking care of the replica set controller internally, right? Then I'm good with that, because the replica set control will take care of my replicas. Then what are the other advantages that I'm getting in using the deployment kind? We'll see them. I just wanted to run this slide, guys, just to understand the flow. In Kubernetes, whenever I wanted to run my application as a pod, I always go and deploy the deployment. The deployment will take care of creating a replica set. Replica set controller will take care of creating the pods based on the number of replicas that you have been specified. Once the pods are running with the labels that you specified, the service will take care of routing the traffic to those pods. Are we good with the statements? Thank you. Right, you see, this is the deployment controller that I'm talking about. In this deployment controller, right, it actually creates a deployment. Inside the deployment, it actually creates a replica set. Inside the replica set, it actually creates a pod. Inside the pod, it actually creates a container. Inside the container, the application will be running. I just have repeated again just to get a better clarity in terms of the hierarchy, guys. Whenever you deploy an application to run as a pod, right, it's very important to do the health checking, right? Sometimes when you deploy the pod, right, so probably your pod may not be healthy, right? So how do we validate the health of your application? Maybe I'll just come back here again. Help me guys in the chat window as and when I'm going. Let's say your replica set controller is actually taken care of deploying the pods, correct? So far. Can I do like this? Probably. Now onwards, rather me calling replica set, can I call it as a deployment? I'm just keep on changing the terms here. Correct, no? Because I only take care of the deployment, right? The deployment internally taken care of the replica sets and all. I'm not caring about those internal things. For me, I'm just deploying the deployment. The deployment will take care of creating the pods for me. The service will take care of routing the traffic. If any pods gets down for any reason, because I have asked for 3 replicas, it will try to create a new pod. The new pod will be get created with the same label, that is true. The problem here is the moment when the new pod is available with the same label, the service, right? The service will get to see, correct? The service will be discovering the pod. Hey, there's a new pod with the same label. Okay, look like let me route the traffic, correct? The traffic will be routed to that pod. But tell me guys, whenever the pod is ready or deployed, do you think the application will be ready at an immediate second that the pod is deployed? No, right? Once the pod is created, inside the pod, the container has to be created. Inside the container, the application has to be deployed. Application has to be started. Then it will start listening on the ports, right? That means what? The moment when the pod is deployed, your application will take some time to do some initialization before it's get ready to start serving the traffic to the end user, correct? If that is the case, right, the moment when the pod is created, what will happen if my service will start routing the traffic? The service will fail, correct? That request will fail. Why? Your pod is not really ready to start accepting the data on the specific port number, because it just created. It may take at least 5 seconds or 10 seconds to fully ready and start taking the request. How do I control that? I should not send any traffic to the pod until unless the pod is completely ready to accept the traffic, correct? That is where I need to do some health checking. Hey deployment, you please do a health check of my pods, whatever is newly get created. Once the health check is processed, then only you please allow to receive the traffic from the services, or else no. That's good, right? So to do those health checks, right, we need to implement a health checking concept, which is the liveness and the readiness concept. I'm talking about the features of deployment, and this is one of the feature. The readiness is the one of the health check. Sorry, right? Whenever you configure the readiness health checks to your deployment, then whenever the deployment has created a pods, right, it will check for the readiness of a pod, in the sense it will verify whether the pod is ready to serve the traffic or not. Tell me guys, what is the very key point here to check the health checks? How do you, or how the deployment will ensure that the pod is ready to start receiving the traffic? What does it mean by pod health? How do you measure the pod health? At which scenario that you ensure that the pod is healthy? It's a simple rule again. If I send a traffic to the port number 80, because that is the port where my application is listening on, right? If I send a traffic to the port number 80 of my pod, if I get a response, the pod is healthy. If I'm not getting the response, pod is unhealthy. Is that the good step to take on? Obviously, right? Because I'm not really caring about the pod or the container or application. If I send the traffic on port number 80, if I get a response, looks it is healthy. It's a simple rule. So you tell to deployment that, hey deployment, you please do a validation of a readiness check. That means you try to send some dummy traffic to the port number 80. If you get a response, you mark the pod as a healthy so that the service will start routing the traffic. Let's say your pod is back, right? Your pod is back, it is running, but the readiness check is failing. That means your pod is not able to respond on the port number 80 as an example. I just put it a different color here, just saying that the pod is not listening on port number 80. Then your service will not send a traffic to that. It will send to only the healthy pod, right? Once once the pod is back to healthy state, then only the traffic will be routed. Good point. The readiness check is the check that it has to do at the time of creating a new pod or at the time of deploying the new pod. Sometimes what will happen, right? When you deploy the new pod, maybe the pod is created properly, container is created properly, listening on port number 80, health check is passing, traffic is received. Tomorrow, all of a sudden, for some reason, right, your pod is going for unhealthy state because the port the port is not listening. Some issue with your application, right? That means what? Monitoring the health check at the time of deploying the new pod is not enough, right? We need to continue monitoring this, correct? Every 30 seconds, we keep on monitoring the health status. The moment when the pod is going unhealthy, please stop the traffic. How do we do that? That is called as a liveness probe. The readiness probe is applicable at the time of deploying the new pod to ensure that the pod is ready. Liveness is the health check concept which will be doing the health status of your pod continuously all the time. Whatever the interval that you specify, right? Let's say 30 seconds. Every 30 seconds, it's keep on doing the health check. If the pod is healthy, get the traffic, or else don't take the traffic. So simple. Now the readiness and the liveness probe checking configuration has to be defined in your deployment manifest file. What is the syntax now? So the document says a lot of examples, guys, because the readiness and the liveness can be defined in multiple ways. There are different ways are there how it can ensure the traffic is healthy, but I'll show you one of the better and easy process. You see somewhere here, readiness probe, liveness probe. This is the configuration. I'll simply copy this whole stuff. I'll just come to my deployment here. Now it should be under the spec section, right? So maintain the indentation. That's it, right? So I'm just saying that the readiness probe, under that I'm telling that, hey, please monitor port number 80, right? Liveness probe, you please check for port number 80. That is where my application is supposed to be listen on. And the interval, how frequently it has to look for the health status. 10 means 10 seconds. Every 10 seconds, it will try to look for the health status, right? Initial delay seconds in the sense, like initially when you deploy the new pod, right? Optional, it has to wait for some time before it start looking for the health status. So it's a check, right? If you specify or else, that's it. Once this is done, you copy this and you deploy this. I'm just cleaning the things just to show you how the new configuration is working, no other reason. When you try to delete the something, right, we can even pause your manifest file, guys. You see this time, when you give the manifest file to the delete command, what were created before using this file, all those will be get deleted for you. So easy, right? You see, deployments are gone, replica set is gone, pods also gone. Now let me deploy one more time. This time I'm just adding the liveness and the readiness probe. Copy. kubectl apply -f deployment. Unknown field under spec template spec liveness probe. So indentation issue. R should be at the same position of your port. So we just need to see the indentation, guys. This is how it should be. How I'm doing actually, right? As per the example, the R should be at the same position of your name, N, right? So just try to match this. That's it. Let me get the new one. kubectl apply -f deploy.yaml. kubectl get the deployment. Sorry, right? kubectl get the replica set. kubectl get the pods. As of now, it is working as expected because I said look for port number 80. It is all healthy only, so the services are up and running fine. If the pods are not healthy for any reason, if it is not coming up properly for any issues, then this ready state, right, it will give you 0 by 1, right? It will show you 0 by 1. That means the container is not ready inside that. What will happen that time? It will first stop the traffic. The traffic will not come to the pod because that is unhealthy. The second thing, the application will keep on restarting. Getting me? Inside the pod, your application will be keep on restarting, and this restart count will be keep on increasing. Why? Because it is unhealthy, it is trying to restart the application inside. That means your container will be restarting, and until unless it is come to healthy state, it will be doing the same thing for you. So that's where we need to come and see why it's failing and start doing the troubleshooting. Good. Now, whenever you deploy the pod, at least in this case, I'm getting 3 pods, right? The container engine is actually trying to allocate some of the processor and memory capacity for each and every pod to run the application, right? So usually the container engine is going to allocate the processor and memory that is coming from the host machine, correct? This pod is currently running on which worker node? The worker node has some capacity, right? Your worker node may be having one processor, 1 GB memory. That is being allocated to these pods for running the application. By default, when you deploy, right, generally the application that is running in the pod will request for the capacity. Let's say The Apache web application that is running in the pod, right? That will tell that, hey, container engine, I need this much of processor, this much of memory. It will be requesting for that capacity. The container engine will start giving that capacity right from the host machine. Got it? I'll just go back to this screen again. So I have the application that is running inside a container, and it is keep on requesting for the container engine. Hey, please give me this much of compute. I need this. Whatever is requested by the application, the container engine will get it from the host machine and will be giving it to that particular application. The problem here is, let's say you have two processors in your container, sorry, in your host machine or in your worker node. Let's say the application A requested that, hey, I need two processors. The container engine will give two processors for this application. Now let's say the other application running in another pod request for one more processor. What will be the case now, guys? The container engine says that, hey, I don't have a processor available for you to run the application. Correct? Why? The processor capacity that is available at your worker node that is already given to one other pod who is requested. Now there is no capacity available for the other pod. That pod will go into pending state just because it is not finding the compute that it needed to run the application. Total how many pods that I can run? As long as there is a compute available, yes, you can run any number of pods that you like it. To avoid all these situations, right, you can set a explicit request and the limit for each and every application. That means, hey, this pod can ask for only one processor, cannot go beyond that. So the container engine will be strictly following your specifications only. It will not give more. Even if the application asks for, hey, I need a two process, the container engine says that no, I can't give you two because based on the configuration, I'll give you only this much. Like that, it is possible to specify the compute capacity requirements as well for your application. Which is the concept of request and the limits. It's a simple configuration, right? So the request and limit is the concept that we need to configure, and the syntax will be like this. Right? So under the resources block, you need to specify the request and the limit. These are the advantages of deployment kind, guys. Okay. Now the request is all about the very first time when the pod is getting deployed, how much compute that I need to bring up the pod into running state. This is the minimum. The limit is all about once the application is in a running state inside the pod, for any reason, if the application demands more compute, more memory, then it will ask for the more capacity. And it can go and ask for this much of limit only. It can't go beyond the limit. That means initially when the pod is deployed, whatever you configured in the request section, that will be given. Later, if it need more, maybe more users are accessing the website, more load is coming in, maybe it need more capacity to handle the situation, then it can go and request for the additional, the limit is so and so. That's how it works. The memory will be like MBs or GBs. Always the processor will be calculated in terms of milliseconds only. That's where you can see the units are M here. That means milliseconds. How many milliseconds for one processor, guys? Any idea? One processor is equivalent to 1000 milliseconds. That's the calculation. If you wanted to get one processor, you give 1000 milliseconds. If you need 1.5 processor, like 1500 milliseconds. That's how we need to calculate, guys. So we can give 500 milliseconds as well, right? Like that. So you define this configuration and you deploy this. Then the container engines will ensure that it is actually allocating only this much of capacity for your pod, not beyond that. That's how I'm trying to balance out the overall capacity, whatever is there in my worker node, right? I'm trying to allocate for all of my pods, right? Whatever the requirement that I have. So the list will go on, guys. As of now, I added the liveness and readiness. Now I'm adding the resource request and limits. All these are I'm giving for my deployment to manage the deployments of my application. Good with this. Now, I think I'll give you one hint now, but the actual execution I'll do tomorrow, right? Let's say currently, maybe I'll do right away. Currently, I deployed my application that is currently running here. A question for you at this time. Did I specify the resources limit and request for these pods? No, right? Because these were already deployed. At the time I deployed these, right, I did not call out that what should be the request and limit. And that means for now, these pods can go and get any amount of compute and memory from the worker node. There is no limit. But now I decided that no, I wanted to set a limit. I wanted to set a request also based on these things. Now the time for me to think about how to update the existing deployment with the new configuration, correct? Because sometime back I already deployed, it is already running state. Now I am trying to think to change the configuration of my deployment, correct? Maybe what kind of configuration change? Maybe I'm just trying to add the resources section. So can I go and update on the existing pods directly or not? So that is where now we need to think of the update strategy. How do I update the configuration change of my existing deployment? That is what I'm trying to look at now. The Kubernetes has a multiple update strategies. We'll call about or we'll talk about those update strategies in tomorrow. What is the best way to update the existing deployment configuration with some other changes, and what will be the impact of that, right? How will that cause any downtime for my running application? We'll call out all those update strategies in tomorrow lecture, but I'm just giving you the hint that sometimes you may be already deployed, it is running fine, but you may need to do some changes. And how do I do those changes? We'll see that in tomorrow lecture.